144. What do we got there? 225? Yeah. 9, let's see, what do we got? 6, 369? Okay. Square root. I have no idea. I don't have this one, so I'm going to trust somebody here. Square root of 369 rounded to the nearest tenth of a foot. Don't screw it up for me. 4. I know it's got to be more than 12 and 15. 19.2. How we looking, everybody? Confirmation? 19.2 feet. Guys have any issues with Pythagorean theorem? All right. Now you got to go on the big boy, big girl math. Can you set up Pythagorean theorem for this triangle? It's a right triangle. Everyone agree? Right triangle. So a squared, b squared equals c squared. Help me set it up. Here you go, 7. Help me set this one up. Give me one leg. 8? Is that an 8? I don't know. I can't remember. Is that an 8? All right, look like a 3 to me. Calm down. 8 squared plus other leg. Okay, hey, everyone take a look. X minus 4 squared equals on the other side. X squared. Got it. How far have we come? How are you going to treat this right here? Hopefully not with x squared minus 16 or x squared plus 16. What do we have to do? Probably off to the side somewhere, I do x minus 4 and x minus 4 and FOIL, double distribute, whatever you called it. Yep, so I'll ask somebody that in a second and give you a chance to do that. And don't get nervous. I'm not going to ask you to factor it. You'll see what happens. Here you go, 10 when you're ready. What do you get when you FOIL that out? Thank you. Let me clean this left side up. Let's clean this left side up. I don't like that x squared in the middle. X squared minus 8x, 64 and 16, 80. What do they both have on either side of it? They both have x squareds. Eventually, what's going to happen out when I move one over? See ya! They're gone, right? They'll be gone. So I'll have negative 8x plus 80 equals 0. They'll be gone. All right, how do you want to solve for x? Don't make it complicated. 16, what do you want to move over? How? Okay, negative 8x equals negative 80. X equals 10 spot. Yep. Anything from you guys? Because that's Pythag done. Ready to go on to the next one. All right, I'm going to clear this all out here because it's driving me nuts. Everyone all right? Pythag. Okay, here we go, guys. Here we go. You told me you don't remember anything about it, so I'm going to slow it down a little bit. A 30, 60, 90 triangle and a 45, 45, 90 triangle. Anything you remember, anything. We're not going hardcore here. We're just going basics, but anything. Just throw something out there. Matt, sure. Okay, all triangles add up to 180 degrees. I got that. No, okay, that's fine. All triangles have 3 sides. How about that obvious one too, huh? All right, touche. We'll go. Well, all right. I'm saying anything too. We got it. Thank you. All right. Let me rephrase that. Anything about the sides of the triangles up here? I should have said that. Sorry, Matt. Anna, going to take it. What do you got for me? There is some. We got a DJ in here. All right. Sorry, Anna. The sides have some relationship. Correct. We're getting there. 45 and 45, the sides across from them are the same. Okay? If that's 6, the side across from the other 45 is 6. All right? They're both the same. What I'm going to do is I'm going to call that x and x. Could be any side lengths. All right? For the 45, 45, 90. X and x. If you know that side, you know the side across from the right angle, the hypotenuse. That'll be x times, anybody? Going to go dig deep here. Square root of. That's coming up in the next one. 2. Okay? So you could have 6, 6, 6 radical 2. 10, 10, 10 radical 2. Right? Whatever the side is across from the 45, you multiply it by radical 2. 30, 60, 90. Okay, hold on. The side, where's the smallest side up here? Anybody know the smallest side? Across from the smallest angle? In our case, 30. So the side across from 30 is always x. The hypotenuse, double it. The hypotenuse will be double the side across from 30. And the side across from 60, x radical 3. All right, I'm not going to get too hardcore here with you. Let's see now, let's use it. Go ahead, draw this first triangle here in part A. So angle C is the right angle. Angle A is 30. Does that say BC equals 8? Okay. What type of triangle am I dealing with? 45, 45 or 30, 60? 30, 60, right? All right. What's across from the 30? 8. And I'm looking for the side AB, which is across from the right angle. What's the relationship between the side across from 30 and the side across from the right angle? I got to double it, right? So what's AB going to be? 2 times 8, 16. Real quick, I know it's not asked, but what would be the side across from 60? Side across from 60, 8. Put what with it? 8 radical 3. Okay, the side across from 60. Go ahead and get your ladder leaning up against the wall at a 45-degree angle. Ladder is 12 feet. Where am I going to put the 12? Hypotenuse, yep. Ladder's 12 feet long. How far up the wall does the ladder reach? So which one am I trying to find here, the vertical or the horizontal one? How far up the wall the ladder reaches? What type of triangle is this? 45, 45, 45, right? Okay, I'm given the side across from the 90, which is x radical 2. And I'm trying to get to x right here. Everyone agree? Okay, so here's what we're going to set up. 12, that's the hypotenuse, right? And what's it equal to in the 45, 45, 90? What did we just label as the hypotenuse? So 12 equals x radical 2, and now we're going to solve it for x. Okay, 12, the hypotenuse, is equal to x radical 2, solve for x. What do I have to do on both sides here? 11, what do I have to do on both sides? Oh, I'm just solving for x. How do I get rid of the radical 2? Divide both sides by radical 2. I don't know. Don't go to your calculators. What's the direction say? Simplest radical form. I don't want a decimal here. All right, let's make your Algebra 2 teachers proud from last year. How do you get a radical out of the denominator? Make them proud. Come on, make them proud. How do I get a radical out of the denominator? Go ahead, Declan. What do you got for me?
So you divide it and you make it like 4, or radical 4 times radical 3. Oh no, that's simplifying a radical.
Yeah, you're simplifying, but that's not even a radical 12, so you can't simplify that. All right. Anna, you're the only one that took Algebra 2 last year. Go ahead. You multiply top and bottom by the radical. Look familiar? Come on, guys. Anybody? Multiply top and bottom by radical 2. Anybody going? Yeah, maybe Matt. Yeah. Oh, were you? Yep. Yep. Then you were going to give me square as 4 sides, probably, right? Okay. All right. Oh, you kids. All right. Why do we do that? Well, what happens when you multiply a radical by itself? This will just be 2. The number underneath. Up top, 12 radical 2. One more step. What can you divide here? I can't touch the radical part. That's underneath the radical, but I can touch 12 and 2 to give me what? 6 radical 2. Oh, boy. Hypotenuse was 12. X radical 2, I got that off my triangle by knowing the sides. X radical 2. Solve for x by dividing by radical 2. Set up C. Go ahead. Write all your angle measurements for C for me. Boy, here we go. All right, ready to help me find all the sides now? Take your time. Take your time. Name the triangle. Give me the 3 letters of the triangle that consists of a 45, 45, 90. What triangle up here is a 45, 45, 90? Here you go. 4. What triangle up here is a 45, 45, 90? Everyone agree it's BCD. Nice job. BCD. Okay. If you want to draw it out, draw it out. If not, keep it there. I'm going to just draw it out. You don't have to. If you can just deal with it on the paper as it is, fine. Let's see, BCD, that was 45, right? That's 10. Three, what's across from the other 45 then? 10. They're both the same, right? So CD equals 10. Got it. Got it. CD equals 10. What's the hypotenuse? Use your rules. Use your rules. Look back up at top. What's the hypotenuse? If both the legs here across from the 45 are 10, what's your hypotenuse in radical form? 13? Okay, ready? What's the rules? It's x, hypotenuse is x radical 2. What's my x in this case? 10, so what's the hypotenuse? Done. 10 radical 2. And that's BD. Everyone see how I filled out the 45, 45? Hannah, you good back there? 10, 10. Across from the 45s are the same. Put a radical 2 with it for the hypotenuse. Good? Okay, do you see a 30, 60, 90 triangle here? Name the triangle with 3 letters. That's a 30, 60, 90. 2, can you name that triangle? BAD, the entire one, the big dog. Got it. Because that was 30. This angle up here will be at 60. Now you're chirping. Good. Good. What side do you already know, though? You already know one of the sides in this triangle. Which side do we already know was given? Here you go. 8. What side's given? BC. How long is it? 10. And it's across from what angle? The 30. Here we go. So if 10's across from the 30, what's the hypotenuse? They're across from the 90. If that's 10, what's your hypotenuse then? Look back if you need to. 6. What's my hypotenuse? What's the relationship between the side across from 30 and the side across from 90? All I have to do is what? Okay, go ahead. What's the hypotenuse? What is the side across from 30? And what did you just tell me to do to get to the hypotenuse? Okay. There we go. Double it. So that's going to be 20. AB is 20. And then I have one more side, CA. Look back at your triangle. Look at what the side across from 30, what do I have to do to it to get to the side across from 60? Multiply it by, not 2 anymore, but 4. Multiply it by. Begins with an R, ends in radical. 10 radical 3. All right. Anything here? Yep. Which 3? From the rule. Yep. Always. If you know the side across from 30, you multiply it by radical 3 to get to the side across from 60. Every time. It's always radical 3, not going to be radical 10 or anything else. Always radical 3, and you always double it to get to the hypotenuse. Okay?
Radical 3 isn't always like, I don't know what you would call it, the spine or kind of like this. On that one, it's like the left.
Okay, okay, well, here.
Is it just like flipped over?
It all depends on where the 30, hey, okay, I'll put the 30 here now.
Oh.
So now that's x radical 3. It's always across from the 60. Okay. No matter where the 60 is. Good? Yeah. And did you just say the spine? Yeah. Okay, I just wanted to check. All right, we're packing about probably 3-4 weeks of geometry in one day here. There it is, your friend. I know you've definitely heard of that. Don't give me this business either. You've definitely heard of that. Did your teacher ever tell you that's a real person? That's actually, that's Pocahontas' brother. Pocahontas had a brother. Conveniently, he was named Sokotoa, and that's by coincidence, mathematically, how we figure out all this stuff. Sokotoa, all right? Pocahontas' brother. Everyone knows Pocahontas, right? I don't think he starred in the film, though. But he's there. Might have been like the black sheep of the group. I don't know. All right. Pocahontas' brother. Look it up. All right, here we go. Moving on. Well, first of all, what the heck does all this stuff mean? Anybody remember the S? Don't sine. It's not sin, it's sine. Yes, S-I-N-E, sine is equal to O for opposite over hypotenuse, C for cosine, adjacent over hypotenuse, and then tangent, opposite over adjacent. All right, so we're better shape than the 30, 60, 90 triangles, huh? All right, here we go then. Let's use it. Angle C is the right angle again. Angle A is 37 degrees. AC is 20. Find BC to the nearest tenth. Quick question before we begin. We started this day off by using Pythagorean Theorem. Why is that not an option here? It is a right angle. I don't know anything about the hypotenuse, right? So I can't use Pythag. Why can't I just use those two special triangles I just showed you? It's not 45, 45, and it's not 30, 60. Darn it. Okay, so now I'm forced to use SOHCAHTOA. All right, so here we go. Everyone see the acute angle they gave me, 37. Take a look at that angle. How can you describe where side X is here? Is it opposite the hypotenuse or adjacent for the 37? That is the opposite side. Can we all be in agreement there? That's opposite. And this is how I roll. I always like to just put a little O there to remind me that I have the opposite side. What is the 20 referring to? Now you only have two choices because you took opposite out. Is it the adjacent side or the hypotenuse side? Adjacent. All right, so what sides do I have? The opposite and adjacent. Take a look up here. Where is adjacent and opposite with each other? With the T, right? For tangent. All right, so that tells me out of these three, I'm going to use tangent. That's the abbreviation, tan. What's the angle I'm working with? So the tangent of 37 is equal to, now we have to figure out, is it 20 over x or x over 20? Read it. Tangent's equal to? Opposite. What was the opposite side we labeled? X over adjacent, 20. Now the question is, how do you solve it? I would always cross multiply, yep, because this is over 1. So I'll have x times 1 is x. Tangent of 37 times 20. Now some of you aren't going to get the correct answer. This is 37 degrees. So your calculator has to be in degree mode right now. This is not 37 radians, 37 degrees right now. So in your calculator, make sure we're in degree mode. I'm not. What do we got? Tangent of 37. So I have tan of 37. And yes, you have to close it. You can't put the multiplication symbol. Times, what are we multiplying it by? 20? And what are the rounding directions here? Nearest tenth. So 15.1. Calculator giving them trouble. Calculator giving you trouble at all? What's a thing? Yeah, anytime you clear your memory in your calculator, like before a test or Regents exam, it automatically defaults back to radians. Yep. Crazy. Are we all good? Anything? All right. How are we doing here? We almost home here? Oh, crap. No, we're almost. All right. Okay, ready? Oh, more vocab. Perfect. Find the angle of elevation. When a student 170 centimeters tall casts a shadow of 170 centimeters. All right. Well, I'll talk about this elevation here in a second. We got the tall student, right? 170 centimeters. I don't know where this comes from, and it drives me nuts when I see students draw shadows. You let me know when you go outside and the shadow is beaming off your forehead, because this is what I'll get right here. Oh, here's his shadow right here. Since when? That literally means your shadow is beaming from your forehead down to the ground if you put 170 there. Where are usually shadows? On the darn ground, yes. I'll ask, angle of elevation? Anything? From the ground up. Elevate, like an elevator. Well, elevators go up and down, never mind. Elevate your eyes up so you're on the ground up. So the angle of elevation is from the ground up in the corner here. Do you remember what the other angle was called? There's another one, angle of elevation and angle of... Good talk. All right, moving on. I'll just stop there. All right, here we go. Pythag's not going to help me out because that'll find the hypotenuse. I need to find the angle. All right, opposite adjacent hypotenuse. Here's my angle, right? Here's my angle. Opposite adjacent hypotenuse. Okay. What about the other 170 right here? Adjacent or the hypotenuse? Once again, what do I use with O and A? Tangent. All right, so tangent. What's your angle? X. I don't know it. I'm going to try to find it. Equals, here we go, opposite side. 170 over adjacent side. Okay, this is the one instance where I do not want to cross multiply. When I find an angle, I want to use something else on my calculator. Everyone look at your sine, cosine, tangent button right now on your calculators. Do you see what's right above it? The -1, the inverse. Yes, everybody see the inverse is right above? That is what I use when I'm asked to find an angle. When I'm asked to find an angle in sine, cosine, tangent, I want to use the inverse button. So here I'm going to go inverse tangent. And what's the fraction you guys just made up? 170 over 170. And it will produce the angle back. So we use the inverse of tangent with 170 over 170. And that'll be 45 degrees. Yes?
If those two sides are the same, do you have to do all that? Because you know it's a 45.
Okay, you got me there. No, you don't. But if they were different, I would have to do the inverse. Nice job, babe. You're welcome. Nobody knew the other type of angle? Well, we take a look at C. You have elevation and you have depression. Yes, depression. All right, so let's get our right triangle here. (190 feet high). The angle of depression. All right, everybody stop, please. The angle of depression is not the other angle in the triangle. All right, that was elevation, everyone agrees? This is not depression. Depression is actually found outside the triangle. All right, so you're actually on top looking down now. So this outside the triangle is 34 degrees. Depression is outside the triangle. All right, elevation, yes, inside, but depression is outside. Find the nearest foot, the distance from the boat to the foot of the lighthouse. So what am I finding, the hypotenuse or the other leg? The distance from the boat. That's about it. There you go, the boat to the lighthouse. Is that my hypotenuse or my, the foot of the lighthouse? The boat to the foot of the lighthouse. Is that the hypotenuse or the other leg? Because it did say foot of the lighthouse, so the bottom. And that is one happening boat. Why can I not use this 35 where it is right now? It's not inside, but I need your help. How can I use that 34 to maybe get an angle here or here? How can I get an angle inside the triangle right now? Subtract. Go ahead, Matt. 180. 180 makes a straight line. To get which one? This one right here? Okay, everyone see, this is a right angle up here. So he's absolutely correct. AJ, you too. 90 minus 34. That angle will be what? 40. Why do I listen to some of you? Why? Did anybody want to find this angle down here? It is 34. Anybody remember what type of angles those were? Alternate interior angles back in the day. It's nuts, all this geometry, I know. All right, now we can solve it though. X, opposite adjacent hypotenuse to 56. Opposite. What about the 190? Adjacent. Oh, I wish we had better examples here, but what am I going to use with the opposite and the adjacent side? Tangent. Tangent of, what's your angle? 56. X over 190, 190 over X. And finding a side or an angle. What are we doing? A side or an angle? A side, so I don't want to use the inverse button, only when I'm finding an angle. And somebody will help me out here in a second. To the nearest foot, 282. I'm going to walk around. You're on your own for part D, or working with people around you. You're on your own for part D. Let me see what you can set up and what you can solve. Okay, what side do you have? Do you have the opposite? Do you have the hypotenuse? What side's the 18? What side's the 20? What must I use then? What's the 18? I'll keep doing this with you here. What's the 18? Opposite, right? What's the 20? Oh, be careful. Hypotenuse is always across from the right angle. All right, this would be the adjacent side right here. Adjacent and opposite are for the legs. All right, so this would be hypotenuse. I know it's not tangent. Can you believe it? It is what, though, with O and H in SOHCAHTOA? Sine. So, yep. So sine. What's your angle? X. Opposite side over hypotenuse. And where are you going on your calculator to do this? The inverse button. Yep, inverse button. Second sine, 18 over 20. Find to the nearest degree. Nearest degree? 64? No? Second sign back there? Second sign? (18/20). 64 degrees. All good? Okay, hey, we got to practice some of this stuff here. All right, I'm not asking for much here. We got to practice some. Bring all your questions tomorrow. We review for the test tomorrow. Quiz.